Hi there, this video is about evidence for the movement of particles in gases and liquids, which are the fluid states of matter. Let us get started. According to kinetic particle theory, all matter consists of tiny particles which are in the state of constant random motion. Particles of a solid state do not leave their mean positions and just vibrate about their mean position, whereas the particles of liquids and gases, they move haphazardly and randomly. While moving, they collide with one another and bounce off in all the possible directions. Since the particles of solid, they do not leave their mean positions and only vibrate, so there is no question of any spreading of particles of solid. For example, had there been diffusion or spreading in solids of their particles, the centuries-old buildings would have collapsed in no time. So it means that particles of solid cannot intermix with another solid because they are not capable of leaving their mean positions, and hence they are not capable of diffusing into one another. For example, in this figure, say these are the particles of solid A and these are the particles of solid B. If both these solids are brought in contact even for long period of time, their particles won't be spreading into one another, and hence the solids, they cannot diffuse into one another. So there is no diffusion of solid in solid. But on the other hand, the particles of liquid and gases have higher kinetic energy than the particles of solid and move randomly from place to place, have wide spaces between the particles, move quickly, and thus they are habitual of colliding with one another, collide with the neighboring particles. So because of these properties of liquids and gases, their particles tend to spread into one another. So particles of liquids and gases, they tend to spread, and this spreading of particles of liquids and gases on their own is called diffusion. So this spreading of particles is the evidence for the movement of particles in fluids, that is liquids and gases. If motion of particles of gases were absent, they would not have diffused or spread. Similarly, diffusion could not happen if particles did not exist. So it means that diffusion is the evidence for the movement of particles in liquids and gases. Now let us define diffusion. Diffusion is the movement of particles of two or more substances from region of higher concentration to region of lower concentration is called diffusion. So diffusion is the movement of particles of different substances into one another from region of higher concentration into region of lower concentration is called diffusion. As a result of diffusion, homogeneous mixture is formed. Homogeneous mixture is a mixture which has zero concentration gradient everywhere in its bulk and has a uniform chemical composition throughout. The movement of particles of different substances into one another can only be said as diffusion if the concentration gradient occurs between two regions. If the concentration gradient becomes zero, then the movement of particles cannot be said as diffusion. Now let us look into the diffusion of gases. Diffusion of gases can be split into two categories, that is diffusion of gas in gas and diffusion of gas in liquid. Let us first look at the diffusion of gas in gas. Let us first define it. The spontaneous intermixing of two or more gases from higher concentration to lower concentration is called diffusion of gas in gas. As a result of diffusion of one gas into the other, a mixture with the uniform chemical composition is achieved. Now, why do gases diffuse into one another? That is because of these reasons. Number one, particles of gas, they undergo collision. Particles of gas, they undergo collision with one another. So the collision between the particles. And the second reason is that there are gaps between the particles of gases. That is interparticular spaces, means spaces between the particles. Since the molecules of gas move fast and there are large gaps between their molecules, therefore when the molecules they collide, they bounce off in all the possible directions, and doing so the molecules of one gas spread off into the molecules of the other gas. In this way, ultimately a homogeneous mixture of two or more gases is formed. Now let us explain the diffusion of gas in gas with the help of an experiment. This is, say, for example, gas jar A, and this is gas jar B. Gas jar B is filled with air, which is colorless, whereas jar A is filled with vapors of bromine. It is filled with vapors of bromine. This is liquid bromine, that is a volatile liquid, and evaporates off to give red-brown vapors or fumes of bromine. So these are vapor of bromine which are red-brown in color. And the air jar or gas jar with the air has been placed upside down onto the glass plate kept on the top of the jar containing bromine vapors. This is actually glass lid, which is not allowing the intermixing of air molecules with the bromine vapor. Now if this glass lid is removed, the vapors of bromine will start intermixing with the air molecules, and the molecules of air will start intermingling with the vapors of bromine. And if time is given, one can see after a certain period of time that both the jars they become uniformly colored as red-brown due to the vapors of bromine. It indicates that vapors of bromine have spread or moved into the space between the air molecules and in the space in jar B, as a result of which a homogeneous mixture of air and bromine vapor is formed. Before removing the glass lid, there was a higher concentration of bromine vapor in jar A and a higher concentration of air molecules in jar B. As soon as the glass lid was removed, bromine vapors started moving from region of higher concentration into the jar B, that is with region of lower concentration of bromine vapor. Similarly, air molecules from jar B, a region of higher concentration for them, started moving to jar A, a region of lower concentration for the air molecules. This process continued until a homogeneous mixture was obtained in both the jars, and both the jars they got uniformly colored as red-brown. So this uniform color indicates that a homogeneous mixture is formed, and this homogeneous mixture has been formed due to the spreading of gas molecules from one region into the other. So it means that bromine vapor have diffused into the air molecules, and air molecules have diffused into the bromine vapor, and this spontaneous intermixing or spreading of two or more non-reacting gases into one another is called diffusion of gas in gas or gaseous diffusion. So it is obvious from this experiment that if motion of particles of gases were absent, they would not have diffused. So it is an evidence of movement of particles of gas. Similarly, it also proves the second part of kinetic particle theory, that the particles of matter they are in the state of constant random motion. For example, diffusion could not happen if the particles did not exist. Since in this experiment diffusion has happened, it means that the particles they are not stationary, number one, and number two, matter consists of tiny particles. Now in these jars there is homogeneous mixture of air and bromine vapors. So in these jars, although both bromine molecules and air molecules, they are still in constant random motion, but now their movement is not said to be diffusion, since the concentration gradient has become zero. There is no concentration gradient, or there is no concentration difference at different points in space within these jars. So by this discussion we come to the point that diffusion is the evidence for the movement of particles in gases. Now let us see the diffusion of gas in liquid. When a gas is in contact with a liquid surface, their particles, as we know that they are habitual of colliding with one another, and there are spaces between the particles too. So because of these collisions and interparticular spaces, the gas molecules, they start accommodating in the spaces between the liquid molecules, and in this way a gas diffuses into the liquid. And this diffusion of gas into the liquid, it is also called as intimate mixing. Now since particles, they collide with each other, and there are spaces between liquid molecules, and as a result of these spaces and the collisions of gas molecules with the surface of the liquid, the gas molecules or particles accommodate in the spaces among the liquid particles. And this spreading of gas molecules into the liquid molecules when they are in contact with one another is called intimate mixing or diffusion of gas in liquid. Now for example, fizzy drinks, they involve the diffusion of carbon dioxide gas into the liquid drink. For example, these are the particles of carbon dioxide, which are carbon dioxide molecules. These are the molecules of carbon dioxide over the surface of this soda drink or fizzy drink. These particles, when they come in contact with the surface, they collide with the surface of the liquid drink and get chances to accommodate in the spaces among the liquid drink particles, and as a result of this, carbon dioxide gas gets dissolved in this drink, and hence it is called as soda drink or fizzy drink. When the lid is open, pressure over the liquid drink is decreased, and as a result of which some of the dissolved carbon dioxide molecules or diffused carbon dioxide molecules, they escape rapidly, and in this way a hissing sound is heard when one opens a fizzy drink can. Other examples of diffusion of gas in liquid are diffusion of oxygen from lungs into the blood through blood capillaries of the lining of lungs. Similarly, diffusion of oxygen in water is very important for aquatic life, especially for fish to obtain oxygen from the water to continue their life. Now let us look into the diffusion of liquid in liquid. There are two kinds of liquid pairs in general: miscible liquid pairs and immiscible liquid pairs. Liquids of a miscible liquid pair, they diffuse into one another and form the homogeneous mixture. Actually, the molecules of such liquids, they are structurally alike. If the molecules of both the liquid, they are structurally alike, and number two, they resemble in attractions, then the molecules of such liquids, they spread into one another and form homogeneous mixture. For example, this is homogeneous mixture of water and ethanol. These are ethanol molecules and these are water molecules. Since both ethanol and water molecules, they are polar, hence they are structurally alike and they resemble regarding their intermolecular attractions. Therefore, they are miscible and diffuse into one another. In water, oxygen carries partial negative charge because of its higher electronegativity, and hydrogen acquires partial positive charge because of its lower electronegativity. Similarly, the ethanol molecule is also polar. Because of this polar group, oxygen carries partial negative charge, due to its higher electronegativity, and hydrogen carries partial positive charge. So because of these polar nature of ethanol and water molecules, they develop strong interactions when their molecules come in contact with one another, and hence ethanol, it diffuses into water, and water molecules diffuse into ethanol molecules, and as a result of this, homogeneous mixture is formed. So this is a homogeneous mixture of ethanol and water. Now the question arises that do all the liquids diffuse into one another? The answer to this question is no, as we have studied above that only those liquid molecules are diffusible into one another which are structurally alike and have resembling intermolecular attractions before mixing. But it is not the case with all the liquid pairs. Some liquid pairs, they do not have their molecules structurally resembling and resembling in their intermolecular attractions. For example, water and carbon tetrachloride, it is also called as tetrachloromethane. It's a colorless liquid like water, but it is not miscible with the water. Water is a polar molecule, whereas tetrachloromethane is a non-polar molecule. It is a non-polar molecule, as it is obvious from their polarity that molecules of both these liquids, they do not resemble structurally and also are unlike regarding their intermolecular attractions. So when we take water in beaker followed by the addition of carbon tetrachloride, we see that two distinct layers are formed and each layer is a pure liquid. Means carbon tetrachloride molecules, they are unable to diffuse in the empty spaces between the water molecules. The reason is that both these liquids, they are unlike both structurally and regarding the intermolecular attractions. Therefore, they cannot diffuse into one another. Now let us look into the diffusion of a solid in liquid. Here again the question arises that do all solids diffuse into liquids? The answer is no. Only those solids can diffuse in the given liquid which are soluble in that liquid. So if solid is soluble in the given liquid, diffusion occurs. But if the solid is insoluble in the given liquid, then no diffusion occurs. For example, silver chloride does not dissolve in water and hence its particles cannot diffuse into the empty spaces of water. But particles of potassium manganate 7, when they are added to water, diffusion occurs, and after some time, if the mixture is let to stand undisturbed, a homogeneous mixture is formed, which is actually aqueous solution of potassium manganate 7, which is uniformly purple colored solution. For example, let us perform an experiment. If a crystal of potassium manganate 7 is placed at the bottom of beaker containing water, when the mixture is let to stand undisturbed, a purple colored solution can be seen all around the crystal of potassium manganate 7 crystal. Formation of this purple colored solution is an evidence that particles of potassium manganate 7 have diffused into water. Actually, the water molecules, they develop stronger attractions. Water molecules, they develop stronger attractions with the particles of potassium permanganate in the crystal and pull them out. Means from the surface of crystal of potassium permanganate, its particles are detached by the interaction of water molecules, because the water molecules, they are colliding with the crystal of potassium manganate 7. As a result of that, the particles of potassium manganate 7, they are detached from the crystal and now they are moving freely and randomly like the molecules of water. Therefore, they start accommodating in the empty spaces among the water molecules in the neighborhood. As a result, in the vicinity of the crystal of potassium permanganate, a purple colored solution can be seen. If the time is given to this mixture, the entire mixture in the beaker that becomes homogeneously purple in color. It indicates that particles of solid has diffused into the empty spaces of liquid water. So conclusively we can say that only those solid particles can diffuse into the liquid which are soluble in that particular liquid. So as a result of this diffusion, homogeneous mixture of potassium permanganate and water is formed, which is actually aqueous solution, and that is a uniformly purple colored solution. So this was an example of a diffusion of a solid in liquid. The solids which are insoluble in the given liquid, they cannot dissolve, and hence their particles cannot diffuse in that liquid. If you liked the video, please do subscribe my channel and hit the bell icon so that upcoming video lecture on chemistry may not be missed. Sharing is requested too. Thanks for watching.